Now that we know how heat is transferred, let's see what happens to that heat once it comes into the earth. So these percentages are percentages that you will definitely need to know. They are pretty much a go-to question with the NCFE. So they are statistics that you will need to memorize. So once sunlight, solar radiation, comes through the atmosphere, 50%, so half of all of that energy, actually comes down and warms the Earth's surface. And so we are very thankful for that, because that is what makes this Earth a warm, livable place. 20% of that energy gets absorbed into clouds, and then 30% of that energy is actually reflected back out to outer space. So we are only getting about half of the energy of the energy that the sun sends to the Earth, and that already warms the Earth a good bit. So we're only getting half of that, though. One thing that helps me keep these numbers straight is the least likely place that I expect solar energy to be absorbed is in clouds. And so I always remember, because clouds are the least likely place I expect radiation to go, that is the one that has the least number. Okay, so 50% hits the surface, 20% goes into the clouds, and then 30% is reflected right back away. Again, make sure you know those numbers. If you can do something kind of like I did with the least likely place I expect it to go has the least number, whatever helps you remember it, make sure you do that, because these are numbers you're just going to have to make sure you do memorize. Hopefully you are about done writing this, but I will give you just one more second before we move on. Okay, so let's continue. Now we're going to look at something called the albedo effect. So all that the albedo effect means is radiation that's reflected by any surface. Now, radiation can be reflected by a bunch of different surfaces. For instance, think about if you had a mirror outside. You could reflect solar radiation with that mirror. You can reflect solar radiation with anything that's light in color. For instance, snow. So I don't know if any of you have ever been snow skiing before, or snowboarding, and I haven't ever been, too scared to go. But if I did go, one thing that they usually have is the goggles that you wear are actually a little bit tinted, because if the sun is out while there's still snow on the ground, the albedo is very high, meaning the snow reflects that sunlight up, and it can actually sunburn you even though it's very cold, and it can just be like a blinding light. Now, some of you may have noticed this whenever we have had snow in the past. If the sun does come out, it's really bright. Or you can be inside and then open the door, and if you have like really bright cement, then that cement or that sidewalk could reflect that solar radiation back up, and it's just like a blinding light. So albedo just means reflection by any surface. We're going to look at albedo specifically with clouds, because clouds do reflect solar radiation. As we just saw, 20% gets absorbed into it. So if it's during the day and clouds roll in, then those clouds reflect the solar radiation away, and that is going to make temperatures cooler. Now, this is something that you're probably familiar with, because if you're ever outside on a hot day, if it becomes cloudy, the clouds roll in, you're in the shade, and so it instantly feels cooler. Well, the reason it's feeling cooler to you is because those clouds are reflecting the solar radiation away. And so you can see that in this picture. The clouds come in, they're blocking the sunlight, so they're shooting it right back out away from the surface, making it feel nice and cool, which we all like on these nice, hot, humid summer days that Greenville has so often. So albedo in the day, radiation is reflected away, and the temperatures are lower. And that actually kind of rhymes. Albedo in the day, reflection goes away, temperatures are lower. Now, some of you may want to draw a picture kind of like the one to the side, showing you this radiation reflecting away. If so, that is a great study tool. So that's what happens during the day. So what do you think happens if it's been a warm day and then clouds roll in at night? Well, at nighttime, there's my question for you, but at nighttime, the clouds actually block radiation from leaving, and they reflect it back down to Earth. So they're basically trapping in the heat. So during the day, and I'm going to come right back to the slide, during the day you see the radiation goes away, and at night it can't leave. It's getting stuck there. So the clouds come in, the radiation wants to escape, but it can't, and so the temperatures are actually warmer. So albedo just means reflection of radiation. We know that clouds are going to do that. They have an albedo effect, and that albedo effect is different whether it's day or night. Daytime, the sunlight goes away, making temperatures colder. Nighttime, the clouds keep radiation on the surface. It's kind of like it's tucked it in. If you ever had your parents or someone tuck you in at night, that's what the clouds are doing. They're tucking in the heat and they're keeping it here. So if you ever, usually it gets colder at night, but if you ever went outside one summer and it just felt a lot hotter and muggier during the nighttime than it did earlier that day, it's probably because of clouds rolling in. And so then you can tell your friends that that's just the albedo effect, and they'll be super impressed with you because you sound super smart. So there is your albedo effect in the day versus at night. Make sure you know those differences. Okay, moving right along. That's just a picture showing you the representation. So y'all can look at that on your own. And now we are going to do a fun little connect the dots brain break. So I printed out some connect the dots. I used to love these things as a kid. And this brain break actually has a purpose. So you're going to get just about 2 minutes to finish your connect the dots. If you don't finish it in 2 minutes, then you can finish it for fun later. But you got about 2 minutes. Hope you enjoy it, and go ahead and pause the video. Okay, I hope you enjoyed your connect the dots. The reason why we did connect the dots is because we're about to look at something called isotherms. Isotherms are lines that connect points of equal temperature. So they are very much like connect the dots. The temperatures being the dots, and then the line would go through and connect any of them that are the same. Now, whenever you hear the word therm, or the little abbreviation therm, you probably think heat, or thermos, thermal, something like that. A therm always has to do with heat. So whenever you see isotherm, think thermometer, thermos, think temperature, and that can help you to remember this. So here you have a weather map, and this weather map has isotherms. They then colored in the isotherms based on the temperatures. Now this is going to make it a lot easier if you're a meteorologist to figure out weather patterns, pressure patterns, if you can visibly see it like this. So that's kind of the purpose in doing an isotherm. It shows you the connections throughout the country and everything like that. So here is an example. Usually I'd have y'all come up to the board, but I'm just going to do this because it'll be easier. So I have the map of the U.S. and I have a bunch of different temperatures. To make an isotherm, I'm just going to find one. So let's start here at 20. So I'm just going to connect all points that are 20. And if I want to connect them, that's just fine. So all of those spots are 20. Then you go out and you find 30. And you go around and you connect all of your 30s. Now notice this 25 is just kind of chilling here in the middle, okay? If I don't see anything else to connect it to, I can just leave it alone, okay? That's kind of a filler thing. Then you go to 40, and I have all these 40s, and I connect them, and then I have 50. Now notice, there's not really another place for my 50 to go. The next 50 that I see after I do this one over here is way on the other side of the country. What I cannot do with an isotherm is get my line, go around here, and all the way over. Because do I have any data for this section over here? No, I don't. So if I did that, then you are making up data, and that's just wrong. So you never do that. You would just connect your little line, and then you would move right along. So I could continue on with 80. And so on, and then you're done. So that's all it is with the isotherm. If you could do connect the dots, you can do isotherms. Just make sure you never loop around the country in a place you don't have data. Okay, moving on. We are now going to do chunk 1 of your study guides. The reason I have chocolate chip cookies is because they have chunks of chocolate chips, and this may make some of you hungry. But Unit 3 is a really big unit. And so instead of giving you the entire study guide the day before the test and then you have a ton of homework to get done, I thought it would be a lot better if we could chunk it, giving you one section at a time throughout. There'll be 3 chunks total. That way on the last day, you just have to finish up a couple small pieces of a study guide, and therefore you shouldn't really have any homework. So you're welcome. This also is a good review, and who knows, maybe one day when I get back, I'll bring you chocolate chip cookies whenever we do our chunks. But you're going to go ahead and in this video, while you work on chunk 1, make sure you are filling out your study guide with no notes first. Okay, it is pointless if you are looking at your notes because your brain confuses with what looks familiar with what you know. So do this correctly to make sure that you are really getting everything you can from this, okay? And enjoy your study guides.